Black holes, the most extreme objects in the universe. Born where massive stars collapse under their own gravity, squeezing matter tighter than anything nature can create. Some black holes are enormous, millions of kilometers wide, but the most dangerous kind are the small ones. A stellar mass black hole, 10 times the mass of our sun, but only 30 kilometers wide. Small enough to fit inside a city. Powerful enough to tear a solar system apart. But what if one of these black holes drifted too close to Earth? What would really happen? Let's find out. Most black holes stay anchored where they were formed. Some don't. Some are rogue black holes. Dark, silent wanderers thrown out of their star systems by violent gravitational slingshots. Astronomers estimate our galaxy contains 100 million black holes. Millions of them may be drifting freely through the Milky Way. The terrifying part? They're invisible. No light, no heat, no glow. We only detect them when they pass in front of other stars, bending their light like a magnifying glass. A phenomenon called gravitational microlensing. So if a rogue black hole were coming towards us, we might not see it until it was already dangerously close. The first warnings wouldn't come from Earth. It would come from the Oort cloud, far beyond Pluto. This region is filled with trillions of icy bodies, barely held in place by the sun's gravity. They are so weakly bound that even a small gravitational nudge can knock them loose. As the black hole enters its outer solar system, still tens of trillions of kilometers away, its gravity begins steering this cloud. Comets start falling inward. At first, it looks like a coincidence. But over centuries, Earth would see an unusual rise in meteor showers and comet impacts. These would be the first subtle signs that something massive and invisible was approaching. As the black hole gets closer, the effects become impossible to ignore. Even a small shift in Jupiter's orbit, as tiny as 1%, would destabilize the delicate gravitational balance of the entire solar system. Earth's orbit may become more elliptical, causing harsher summers, colder winters, unpredictable climate cycles. Moons drift slightly out of position, asteroids get redirected, and more. The solar system enters a slow gravitational chaos. Once the black hole comes within a few astronomical units, the situation becomes catastrophic. Loose gas, dust, and icy objects spiral toward it. They collide, compress, and heat to millions of degrees, forming a glowing accretion disk around the black hole. This is when we finally see it. A faint ring of light, background stars warped into a perfect circle, X-rays and gamma rays screaming from the superheated disk. This would be the first visible proof that our destroyer had arrived. As the black hole reaches a few million kilometers from Earth, tidal forces become deadly. Tides on Earth are normally caused by the moon, but the black hole's gravity is over a billion times stronger. The side of Earth facing the black hole feels a much stronger pull than the far side. This difference begins to stretch the planet itself. The process is known as spaghettification, stretching of objects by extreme tidal forces. Oceans rise into enormous tidal waves. The crust fractures. Volcanoes erupt worldwide. Earthquakes ripple non-stop through the mantle. The atmosphere is torn away into space. The surface heats until snow glows red hot. Eventually, the entire planet rips apart into a stream of molten debris, spiraling into the black hole. Earth becomes just another meal. There's something even stranger. Time itself begins to malfunction. Near a strong gravitational field, time moves slower. A phenomenon predicted by Einstein called gravitational time dilation. From far away, Earth would seem to slow down as it approaches the black hole. Every second would stretch and stretch until it almost freezes near the event horizon. But for everyone on Earth, time would feel normal, right up until the final moment. In a black hole's gravity, even time becomes a victim. A rogue black hole drifting near Earth is terrifying, but how likely is it? The real answer: extremely unlikely, but not impossible. The odds of a 10 solar mass black hole passing close enough to affect Earth are estimated to be 1 in 100 million per billion years. Space is massive. The distances between stars are enormous. But because black holes emit no light, We can't completely rule out the idea that one is quietly drifting through the galaxy right now, invisible, undetectable, and deadly. Black holes represent the extreme edge of physics, small, dark, and impossibly dense, yet capable of reshaping entire worlds. They can distort light, warp time, and tear apart planets, but they also help shape galaxies, and may even play a role in star formation. For now, Earth is safe, but our universe is full of wonders and monsters hidden in the darkness. And that's what makes space both terrifying and breathtaking.